In this lesson, I'm going to teach you how to sketch a radical function given the graph of a linear function. So starting with the example that I have here, for the given graph, sketch the graph of y is equal to the square root of f of x. So we're given the graph of f of x, which is a linear function, and we want to graph its corresponding radical function. So there's 4 steps in doing this. The first step is to define the domain of y is equal to the square root of f of x. To define the domain, you know that f of x has to be greater than or equal to 0 because you cannot take the square root of a negative number. So you're going to use that property to define your domain. So going back to the original graph here, y is equal to f of x, you're looking at the part of the graph or the piece of the graph where it's greater than or equal to 0. In other words, where it's above the x-axis. So what you want to do is label that part of the graph. So label the x-intercept. So you're going to start there. And the graph that lies above the x-axis is defined by this piece. So that defines the domain of the radical function, and it's everything to the right of -2. So x has to be greater than or equal to -2. That's the domain of your radical function. So you have a general idea where your graph is going to lie with respect to this domain, but we still don't know the shape. So step 2 helps you define the shape a little bit more. So you want to mark the invariant points. So from my last lesson, I've taught that the invariant points occur when y is equal to 1 and y is equal to 0. So you're going to find those 2 invariant points on your graph. Let's start with y is equal to 1. Okay, so find 1 on your y-axis, and you're gonna mark down the point on the graph with that y value. So if I go to the graph, there is the invariant point, and that's defined at -1, 1. So that's the first invariant point. The second invariant point occurs when y is equal to 0. So find y is equal to 0, which is right at the origin. You're gonna trace where that point lies on the graph, and it's right there. So it's actually the x-intercept of the graph. So that is the second invariant point, and that's at -2, 0. So we know that these 2 points lie on the square root of the graph, but we still don't have a general idea of what the shape looks like. Okay, so we know the domain. We have 2 points on the graph already. So step 3 actually asks you to identify other points above the x-axis to help you draw out the general shape. So I have a handy dandy table here, and what the table wants you to find are 3 different points on your original function. So if we're taking a look at the original function here, find 3 points. So I'm going to use -1.5 and 0.5. So this point right here, that could be 1 point. So if I want to label it in my table here, I have -1.5, and the corresponding y value is going to be 0.5. Okay, so we need 2 more points. I'm going to pick the, actually the y-intercept is very easy to read. That's a 0, 2. So 0, 0, 2. Okay, so that's my second point. Another point, perhaps you can find one all the way to the right here. Let's go 3, 5. So there is my third point. So pick 3 points on the original graph. Now we're going to take the square root of that point. So when you're taking the square root of that point, you're only dealing with the y value. So 0.5, 2, and 5. So let's find the square root of each of these numbers. So pull up your calculator. And if we're going to round to the nearest 10th here, let's go square root of, there you go, so 0.5. Move my calculator there, so 0.5. Okay, and we're going to get an approximate value of 0.7. So that's going to be 1 point on the radical function graph. Let's continue on. So the square root of 2 is going to give me approximately 1.4. So that's the second y value that we have here. And finally, we want to find the square root of 5. So go square root of 5. Okay, and we get a value of approximately 2.2. So what we want to graph are these coordinates. So negative 1.5 and zero point 0.7. So let's graph that point first. So negative 1.5, zero point 0.7 is approximately right there, okay? And then we're going to go 0, 1.4. So go 0, and 1.4 is about there. And finally, we want to go 3, 2.2. So 3, 2.2 is about there, okay? So we have, as you can see, we have 1, 2, 3, 4, 5 points. And the step 4, my last step here is to join those points with a smooth curve. So as best as you can here, if I draw the smooth curve, I'll do it in a different color here, we're going to get a radical function that looks like that. So there is the graph of the radical function, which is represented by the red curve. And that's how you draw a radical function of a linear